Unary minus operator applied to unsigned type, result still unsigned. Then we have to do the same thing here, where we do a 7 minus 1. First part of the day, when you're working on Linux, is just to iron out the little bugs on Windows. Alright, I guess here the problem is new line is undefined, it's unused. Alright, that's my bad. And we're running. Awesome. That's all it takes. Hello everyone. This is a mini episode where I talk about CSV parsing, comma separated value parsing. And the reason we're going to use CSV parsing is because CSV is a very versatile format. It can be edited on many platforms with many tools. Also, let's get the elephant out of the room. My face. What happened to my face? Well, it turns out I have a 2-year-old and we like to play it rough. You should see the other guy. Just kidding. He's fine. I am the victim here. As you can see, he attacked me quite a bit. I got 3 spots because he is a bit of a wild character and we can't cut his nails. So unfortunately, sometimes you get hurt. But it's all good. That's why I look like this. I got my coffee programmer t-shirt on, which means it's time for some serious coding. CSV parsing. Here on the right hand side, you can see this is our creature CSV right there. You can see it. So I got a couple creatures. We got their names right here. We got their types, and it scrolls off to the right. But one thing that sets our CSV apart, this is also valid markdown. And I can edit this markdown on my phone. And maybe it's nice sometimes when I'm feeling creative, when I'm feeling out and about, I'll just tweak the markdown on my phone. So this is a good format to have. One thing I don't want to do is specify the source file a million times. I don't want to copy and paste it. Duplicating rows is easy on PC. I can just do this. I can do all of that, but I don't have to. And also, depending on the tool that I'm using, if I got a creature 2.png here in VS Code, it's nice. I can just align and it's done. But if I'm not doing that, then everything will be shifted and everything will be a mess. So one of the things I want to really support is maybe not all data is going to be there, but you just take the previous data and it's all going to be fine. So I want to be able to omit this data. Likewise for series. Some of the things are unfortunately mandatory. It is what it is. You can make the wheel as polished as possible, but sometimes all you have to do is tweak a number. So these are the characters. These are the creatures we have so far. And I'll show you the creatures. They are awesome. I commissioned an artist. He did an amazing job at these. And then we also have types, HP, attack, defense, blah, blah, blah. Take these with a grain of salt because the battle system hasn't been designed yet. But what's important here is we have strings that are not encapsulated in quotes. Also here, you can see we have 10 dashes. And that's more of a, once one of them exceeds the column width, that's a red flag for me to show, hey, 10 character names for a creature. Maybe that's a little bit too much. Maybe that's going to mess up the formatting at points. So try and constrain yourself to 10 characters. But we do support quoted strings. And now we have a description. Oh, spoiler for the game. We got lynxes. We got foxes. We got crested buntings. Damn right. Clueless. Now you have a clue what we got. Read that if you want to read it. I'm not going to get into it. I'll do a proper introduction of the creatures later. So very simple. How we parse it is we start with a structure. And here you can see we have an ability to here, but we don't have an ability to column in the CSV yet. We have the source and the series. We want to copy these from the previous row. And they have to be present in the previous row. If not, it will give you an error. Type 2, maybe a null string. Maybe something else. By default, a string view that hasn't been initialized is just an empty string view. So the class default is a fine solution for this one. Name cannot be a class default, cannot be empty, cannot be copied from the previous one. And you'll see that we'll have all those rules are encoded when we actually start using it. So, and the rest is just plain old numbers, can be ints. Let's just make them uints. There's no reason to have a negative offset. Doesn't mean anything. We also have a little toString helper function, so we can actually look at something once to prove that we can parse. This is the cooker tool that we have some boilerplate at the beginning, some debugging. It opens a file, it reads the file contents to a buffer, closes the file, and then converts that buffer into a string view. And now it's time to parse the string view. So I've prepared some code on the side, and what I wanted to show is that this is kind of pushing the limits between what you can do with C++ in a clean and elegant way. Maybe there is a way that's better using C++ 23, but I'm not gonna learn any of the new C++. It gets more high level and further away from the hardware that you have. I have no idea what it's doing, and it seems like there's just a lot of memorization for, oh, there's this algo for this, oh, there's this function for that, oh, there's a type trait system inspection concept thing for that. And I don't want to. I want to learn the hardware. I don't want to learn the language, if that makes sense. Anyway, so this is abusing as much as we can, but I'm happy with the code because it is quite concise. Because all I really want to do is I have a creature, I have a name, and I have a name. That's it. Link those two up. If I don't ask for a particular column, don't read the particular column. Maybe it's fine for a column not to exist if I'm okay with having the class defaults. Maybe it's fine if some data sets, some CSVs have an extra thing, but they haven't, not all other data sets have the extra thing. And if it's wrong, give me an error, I'll fix the data set. Bada bing, bada boom. But having the code as easy as possible. So that's all the code I want to write. So the way you use it, and the way I thought it was the most elegant, we'll start off with some of the easy ones, paste it in there. So we pass the object. It's using a macro. And the reason it's doing a macro is because I don't want to specify, by the way, this is a uint32, so use the uint32 parser. I want it to be as magical as possible. Here's the column name, and here's the name of the member on the struct. That's it. So there is an extended version of this macro. I'll put them in front. For example, the source and the series. As I said before, we just want to copy the previous. If they're blank, copy the previous. Type 2 is special because we don't always have a type 2. But if I'm asking the CSV reader, parse this string view, and the string is empty, it will give you a warning. There's two ways you can fix it. You can say the second type is a string that's just empty. Not happy about that because that's an action you can forget. Another thing you can do is say, I'm using the extended version and I want to use the class default if it's missing. And the class default is blank, so problem solved. That's it. I'm sure there's another macro magic you can do. Have this as a shorter thing. Get rid of the redundant mention of reader, nested macros. I'm sure something like that can exist. It is what it is. And here's my favorite bit. That's all I want. Give me an array of all the creatures. Get the rows. This one here is special. That's the skip row number because I have this divider line on purpose. And out it just spews an array of the creatures. So what I need next. So this has been the poorest designed part, but I'll just print an error if it exists. Also the error printing needs to be more up to date. And then it will just write how many creatures it found and we'll print the details. I run this. There they are. That's it. I'm so happy with the CSV reader. This is from my HK library, by the way. So it is BSD2 clause You can find this on GitHub. If not this version right now, you can find it later. Yeah, the creature cooker, that is closed source, copyrighted, but this is just BSD public. You can take a look at it. This is a pattern I do commonly. I have my CSV reader that is a templated class that inherits from GCSV reader, and GCSV reader has a bunch of helper functions that don't really depend on the template. And as a result, I can move some of those functions into a separate compilation unit. The thought process is it speeds up compilation because there's only one version of these functions and not a templated number of functions. Hopefully it speeds up the linker as well because it has less duplicates to go through. So I think if the compiler is smart enough, this is a sensible pattern. Didn't do any measurements. Let's just fingers crossed, hope it works. Let's go from top to bottom. These are our macros. They call add property. Here is the part that I wanted to macro away, where we take the address of the member. That's the third parameter. But in order to get there, we provide the CSV. And what we really wanted to get is the creature part. CSV reader has this typedeft property type. We can do the decal type of the CSV : property type in order to just get the creature. And now we can call address of creature. And address of, pretends to have a null pointer and then references the member of that null pointer to get a relative address to any base pointer. Getting rid of this from the user space is important. And I'm glad it's possible to write this kind of code in C++. What I'm not happy about is that in order to have this code as clean as I can possibly get it, I need to use both templates and macros. But what I do know is that this is probably as optimized as it can be because there's no, I don't know what the structure is. It's magic. And I'm just using reflection to link these things up in runtime. No, at least I know everything's done at compile time, the heavy lifting. This is one of those things. It's questionable, but it works in my brain, where I don't want, just because you use a string view, you also have to include a hasher, and a hasher also includes a bunch of types. I don't want you to include one thing and it just cascades into everything. So if you want to add a string view to, for example, a hash map, it won't allow you because there's functions that's missing from this ordeal. So what you can do is just implement them yourself. So now I have a column name, basically just a string view, some functions to make the compiler happy, as boilerplate as it can be. And then we have property. This name here is just for debugging purposes because we already have a column name to uint32. You'll see later, because later what we do is we figure out, okay, once we parse the header, we map the column indices to the property index. The first step is this here, where we just add the properties, and they can go in any arbitrary order that you'd like. And it also means that this is reusable. Right now we can get reader, get row CSV, or we can do a first CSV, a second CSV. It will parse another CSV file. And the second CSV doesn't need to have these columns in the same sequence or have the exact same number of columns even. Yeah, and here, this is the unfortunate part with get rows, where it is templated code, but it does a function call to the GCSV. Maybe skip rows should be part of parse header, so it doesn't get compiled many times, it just gets compiled once. And here's also a beauty, because we've already gone to the part where we've translated member variables to just addresses and types. When we call parse row, it just takes a void pointer because at this point it doesn't really matter. We also have a class default of t that we store here, and we also send a pointer to the class default. If it takes the class default, it just mem copies whatever is at that address for whatever number of bytes we need it to be, and that's it. So that also means that our CSV parser only does plain old data types. It does string views, ints, and that's it. And the string views are referencing the data that is in the CSV itself. So that's one thing. This may not be clear. Here we have the CSV string view, which is based on this buffer, which is mallocked here. We need this buffer for these creatures. That's just something to keep in mind. So while we have rows, we just add them. If we had an error, then we return nothing. And that's a surefire way of then triggering the user to then check for errors. That's it. So let's look at parse header. We do our string view where we split and chop. We comma separate all our headers. We trim it, get rid of any white space and formatting. We find a column name to property index, which could be a null pointer. So this would say, okay, we have a that I would say in this case, we have an ability one. It's linked to a particular property. The number of that is depending on when it got added. But if we found a column that just doesn't have a property assigned to it, we just write, oh, the property index for that one is -1. We may have properties that are required, but not in the CSV. So this is another error check. We go over all the properties we have. And if they're not class default and we can't find them in our property indices, then unfortunately, we're going to have a missing column error. Yeah, that's our parse header. And then we go into a parse row. All right. We will try and find a new line. If there is no new line, then everything we have should be the entire row. Why do we skip -1 here? Let's see what happens. Oh, that's bad. No closing quote found in Galeclaw. Because this thing, if there's no new line, gets trimmed. Boom. Going over the code, finding bugs where we go. So the lesson here is there's always more testing to be done. Lysvig, Galeclaw, okay. Back in action. All right, little detour. And then we prepare our current row and the rest of the content, which will be chopped off. And then nothing's left. And now we count the columns. And hopefully, because we don't even know if the formatting of each individual line is correct, but what we should assume is that every column matches the target. If not, you just have a garbage file and you should feel bad. What we will do, if we expect an integer, you provide a string. We cannot parse the integer, so here is a warning showing you what column is at fault. There's only so much you can do with such a format in order to keep them coherent. So our whole goal is figuring out the cell, what is inside of a cell. And in this case, if we look here, what I want the cell to be is just creature PNG. 2, Lysvig, nature. And it's fine to have tabs, it's fine to have spaces, to have all of those things in front of it. If we have a quote, then the whole cell is from the start to the end of the quote without including the quotes itself. So that's how we define a cell. So how do we do that? Once it's time to parse a particular column, we chop off all the white spaces we can find, and then we find the first character. If it is a quote, we parse a quote. If it is a comma, then it's an empty cell, which is fine. Like right here, for example, space, 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 comma. All right, it's empty. Or we find a 0. And the way string views work is that if you try and get a first or a last character and it doesn't exist, it will return a null byte. So if we trim all the way to the end, this is the first character, just as with comma. And next time we're here, we keep parsing the next column, peeling the next column off this row. And if we don't have any special first character, we look for the next comma or the next end of line. So cool, we have the cell. We haven't even looked at the type of it yet, but we figured out exactly where it ends, and we trimmed off the column of the whole row, so it's ready for parsing the next column. But now first we have to treat the cell. Question 1, column. We've parsed the headers and we've been counting which column we are at. If we're at column 9, could be 8 off by 1. I don't know how it counts. If it has a property, and defense, for example, has, we want to get it. If not, we don't do anything. We go to the next column. So that's another thing we could do. If we don't have a property index, we probably don't need to trim. Nitpicky optimization, we're parsing text. If we have a megabyte of creature data, that means there's so much content. We should celebrate it every time we cook the data, because it will spend an extra second on parsing so many glorious creatures. We see if it's a required one. If it's missing, we need to error. But if we copy the previous and it's the first row, then we also need to error, because we have nothing from the previous to copy from. Then we have our union with all the types we support, int, uint, f32, and string view, although f32 is not actually supported. I'll get to it one day. If it's an integer, we parse it as an int. This function works on int64s. I never really need to parse uint64s, so parsing int64s is just it solves 99.9% of all my string to integer problems, because I write all these libraries myself. I don't worry about catching every possible use case, because the only use cases are the ones that I can come up with, and I typically just don't have them. So the code doesn't exist, so the project compiles pretty fast. So we do a little check for the min and the max, and then blah, 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 blah. And this is important, the property bytes, because we're just going to mem copy this into our void pointer, right? We need to know how many bytes. Same for float, but it just errors. String view. The reason we have string views and not strings is because we're going to do the mem copy, as I said before. And also it's possible to copy the previous value, which would then mem copy the string as well, because we don't know much about types. So that was this reason why it was just easier to have string views. Plus it avoids dynamic allocation. It just once again means your CSV has to be in memory for the structure to have valid string views. Not a big deal, honestly. I keep hearing about it. Memory management is so easy as long as you avoid too many dynamic allocations. So this is one of those things. At the beginning of the program, load the whole CSV in memory, extract all the data structures you need, process them, and at the end of it, you're done. You throw the whole memory away in one go. That's it. And it works pretty well. It may not work if you dynamically allocate a bunch of individual textures, and some of them may not be needed anymore, and some of them may be, or you have large chunks of a level but now we're talking about proper data. Here we're talking about text. Text weighs nothing. Right now it's 1.88 kilobytes. So if grab one of those calculator thingies, 1.88. Thank you, Dutch localization, for forcing me to type a comma. Let's assume all creature data is just going to be tenfold. And let's assume we have 200 creatures. Crazy high number, right? For our first solo dev indie project, 200 creatures is a tremendous amount. And we currently have 7. Wow, a bit over half a megabyte. And this is the cooking step. This is on my machine. And for some weird reason, my machine has 64 gigabytes of RAM. Excessive, but I thought I'm going to save money in the long run by just having this computer be fine for the next 3-4 years. And all it really means is that every time I want to type something in WhatsApp, I just open a new tab and open web WhatsApp, and I lose the old tab. It's somewhere. I can't find it. Since upgrading from 16 to 64 gigabytes of RAM, it just means I have more browser windows open all over the place, and I can't find anything anymore. Oh well. Anyway, the only allocations we have is loading the file into memory and making a list of creatures. That's going to be an array, bada bing, bada boom. And if it is parsed, we copy the data from our union for a particular size to a particular address. We don't know where it goes, but that's fine. Or if it's class default, we copy the class default. So I left this comment because I knew it was going to confuse me. If missing rule is copy previous, we don't need to do anything. Oh, I know how it works. parse row writes the result into row. Next time we do this loop, we do parse row again with the same thing. So this holds the data of the previous creature. And that's why we don't need to do anything. That's all the CSV reading. And I'm so happy with it. And I doubt this can be made more concise in C++ while keeping all the compile time benefits that are there right now. The big thing I think I can improve here is just switch languages, because this is as ugly as I want my C++ to get. Templates and macros living in unison. There's just no code assistance for this. If I'm in a completely different file, and the easiest thing to write such a line is go CSV reader. Oh, there's these properties. How do I use these properties? Oh, like that. Cool. And then I copy and paste this to whatever file I'm working on. That's how I would see it working. And as promised at the beginning of the video, I was going to do a little review of what we have so far. And this is really great. These are made by Jeremy Rada, and I'll put his socials in the video description. Here's a spec sheet of just a description and some reference photos of the creatures that I was interested in. He just comes back with these 7 designs and he just knocked it out of the park. And these are going to be for the first area of the game. I'm very excited to reveal these to you all. We're going to start with Lysvig. Let's go to the front. Yeah. She is cute, isn't she? Lysvig the Lynx looks carefree and confident, knowing that Sylvigna is around to protect the forest. She's so chill. Forest is being on attack. It's always these predators. There's always humans up to no good. She's calm. She's collected. And there's a big reason for it. Sylvigna is there. Here she is. The protector of the forest. Cute little tail. Bam. There's Sylvigna. Poised and confident in her connection with the forest and her claws as a fallback. She has a mythical quality to it. She can really blend in with the forest itself, and it's hard to really tell what you're looking at when you're going through a forest. But Sylvigna will show herself if you threaten her Lysvigs, or any of the other forest creatures. This mythical quality is going to come back in her attacks and her abilities, and she is almost a must catch when you go explore the forest. I also just love, I can just send an email with, I want a cat with antlers, and I get this amazing thing back. Bam, fantastic. Number 3, Veilkin. Start with the back sprite. A little foxy boy. We got opposite energies here. You want to go for the nature magical, or this little occulty creature. Veilkin the Fox taking notes on how to hunt, eagerly awaiting their time to take point. Wow, these eyes. The artist did such a good job on the eyes and the fur. I'm just in awe of this pixel art. And Veilkin transforms into Rynvar. That's the back. Whoa, look at that. It's a hard choice for me to make, but Rynvar is absolutely my favorite of all of them. Rynvar, with their menacing look, deterring predators from their forest. It is their hunting ground. Don't get confused. I'm here to prey. Get out of here. I just love how the artist decided, I'm gonna leave this pixel open here to have the white fur connect with the white background. I don't know how he did it, but it just looks so natural when he does it. And that's so impressive. I know that just placing one pixel in the wrong place just ruins the whole thing. This dithering is just amazing. How this is open, but you can still know what the shape is. But if you were to draw it out with black outline, you'll probably get the wrong shape, so he just doesn't. It has this V shape on his chest. And you can see it in the back sprite too. Here in the front sprite, you don't see the V shape, but the back sprite's telling you, don't worry, it's still there. Birds, starting with Crestling. A little guy, a little derpy bird. Absolutely fantastically done with the detail in the feathers. And I love that there's a lack of a pupil. Crestling the Bunting, a clueless bird, just discovered flight but can only hunt for apples. Not much of a threat. But Crestling soon evolves into Galecrest. And oh, that's more aggressive. That's more menacing, is it? Damn. That's a bird to contend with. It had some claws before, but it didn't know how to use them. Now it has claws, and it definitely knows how to use them. Galecrest maturing nicely, able to hunt small prey and knows how to escape predators. Helps the Crestling from getting harmed. A lot of territorial animals in this area. There's a lot of fighting going on between them to make sure that their kin stay safe. And you can also see that their beaks are slowly evolving from birds that hunt more worms and insects to a bird that actually attacks other animals. So that brings us to Galeclaw, where we're getting more aggressive. Damn, look at that. This is a no-nonsense bird. It's a powerful stance, powerful beak, big tail feathers. You know what kind of game it's going to be. You know it's going to have quite the wind-based attacks. Galeclaw now hunts predators, but only for sport. Soaring high and scanning through the tree canopy, this territorial terror will protect its kin. So high speed, high attack. Doesn't have a tremendous high amount of defense because it didn't evolve to have confrontations. It evolved to swoop in, get the job done, and leave. You can see the beak once again. 1, 2, 3. From eating insects to biting Veilkins, probably. Man, I'm so excited to work more on the game. Get the fighting in there, get these guys in there, and work on the battle system. And having the CSV parser is the first step in accomplishing that. I'm quite happy with revealing these out in the wild. Let me know which one is your favorite. There's a lot to choose from, of course. So let me know who is your favorite. Is it Lysvig, Sylvigna, Veilkin, Rynvar, Crestling, Galecrest, or Galeclaw? Which one would you add to your party? Let me know in the comments, please. And I'll make sure they're extra rare so you don't get them. Just kidding. Thanks for watching. Thanks for tuning in. Take care, everyone.